So I'm about to start in a moment. Let's see if anybody's joining. All right, let's go. We'll see if anybody will join or not, but at least there should be a recording of this happening. So you'll be able to see it at your convenience. So today I wanted to work a little bit more on Omnigres's HTTP server and see how far I can get. Well, I'll explain the idea, but first, for those who don't know what Omnigres is a project to build a complete business application development platform for Postgres so that you can run pretty much the entirety of your application in Postgres. So that's your web server, your jobs, your API connectors, etc., all within one system so that you don't have to maintain multiple systems and orchestrate them and connect them to each other and get the overhead of different systems communicating with each other. So that's the main idea. And today I'm working on the HTTP server, and the idea behind it is that for every HTTP request that comes in, there is always a query that responds to the request. So let me show you an example here. So let me start the server in my test environment. So let's create extension Omni HTTPD. So it actually creates a default listener on 8080. And you can see it here, say here. So that's the page that it returns. But the way it's done, if you look into this file is the extensions initialization script, and it inserts a query into the handlers table, and that query is basically doing whatever it needs to do to extract the information from the database to show what it wants to show. So for example, let's see, it's extracting number of backends from the stats, and stats are down here. So that's just a CT query where we get some information about the current database. But it's also a query against request, which you don't see in this query. And the way it works, Omni HTTPD augments this query and adds another CT expression called request, where it has all the request details, such as, for example, the path, the method, etc., the body of the request, and so on. And this works pretty well. However, when it gets more complex than this, so in this case, we're always responding with the very same page, regardless of what, of the request, essentially. So we're not really doing any routing here. Say, well, for this page, we should show this, and for that page, we should do that. And there is an example of that elsewhere, and I want to show it, and this will be a description of the problem that I want to try attacking today. So here is another example that's in the tests of Omni HTTPD. And here I want to route based on the path. So here, if you will see these separate expressions, there's one called hello, another called headers, echo, and not found. And what's happening is basically, well, yeah, not found is this one. So I have to sort of cascade the these expressions. So if hello does not respond, I want to respond with headers. If headers don't respond, I want to respond with echo. So you can see this kind of logic. So if the previous query did not return any results, then basically try another query and maybe it will return a result. And so the way it works typically for any query, you need to return at least one row which contains at least one HTTP response. And in this case, this response is an array of headers, and it sets the content type and the body. And also the request is actually joining the request path with users table, so that it can generate dynamic content. In other cases, it's just a body with headers transformed to text, then echoing the request back, and also for everything else, we're actually generating JSON that contains the request method, request path, and request query string. And so we group them together so that when we access this, let me actually create maybe this somewhere. Let's do it this way. So if I split this session and make a request, so let's say get localhost 8080. But before doing this, I obviously need to actually create this one. And as per this test, it's actually establishing a listener on 9000 as well. So we can do this, for example. And as you can see, it will return John Doe. And if there's no matching user ABC, it will return not found. So that means that this handler did not work, but this one worked. And if we want to try, for example, headers, we'll get the headers back. But what I don't like about this approach is that it's kind of wordy. And it's basically, you need to define a query for every path. That's okay. But then you need to create this thing, and you need to maintain it in sync in the right order, how it's done, so that it's done correctly. And so I was thinking that probably one of the best ways to do that would be by essentially using another component in Omnigres that is also in development, and that is processing queries to augment them or do something about them to add additional information. So I can show you some examples of what OmniSQL can do. So OmniSQL basically allows you to take a query in, and let me show an actual result here. So you take a query as a string and you cast it to an OmniSQL statement, and what you get back is actually parsed and deparsed query. So that basically it went through Postgres's parser, and then it was processed back, so it's printed out as text again. And where it gets really useful is modifications of the query. So here's an example. I'm actually building a CTE expression out of this. So we're starting with this expression, select. I know it doesn't really do anything, but here I'm just doing this for test purposes. And I'm adding a CTE called A with an expression select 0. And I'm doing this again for B, select 1. And as you can see, the result is with A, select 0, B, select 1, select. So this allows me to manipulate queries the way I want to do this. All right, so the idea is to take this approach, and instead of having to do, where is this? Instead of having to do this, I want to get all my queries, or perhaps even named queries. So basically that will be the name, and this would be the query. And create an expression that basically does this. So stick all the CTEs in, and then add all the necessary unions to it. So it's going to be a big one, and I'm not sure I'm going to be able to complete it during the stream, but at least I can start, and maybe I will take a break at a certain point. I'll also prepare some materials on the side so that I can look up things that I don't necessarily remember how to do. So you won't see that, but I will try to peek into some of my records here. Just give me a second. I'm preparing that. But yeah, let's think. Okay, I've got the notes that could be useful. So the idea that I had would be that we would have an aggregate function that we can use to create this expression. So let's try an experiment somewhere, at least how it should look like. And we'll go from there. So maybe we should open a new file, like Scratch file. And let's see. So the idea here would be that we'll do something like this. Omni HTTPD cascading query. I don't have a better name for it, but we'll see what will come out of this. From let's imagine there was actually a table with this my routes, right? And let's say routes was defined like this. And obviously, like, you don't need to have a table. It's just so that we can visualize this better. So let's say, well, I don't really care about IDs right now, but basically there will be a name, and that would be text, and it could be null, so maybe we can generate it automatically. But for now, I don't want to do this. So let's say all names should be actual names, not just omitted ones. And then the query would be some string, also not null. And the idea would be that we'll stick this into the function that would take the name and the query. And what it should return is essentially a string, or a string that contains the query that will look like this. Let's say we inserted something into insert into routes name query values. Let's say test, and this will be a select omni httpd response body. I want to make this a little bit easier, so let's do it this way. Body test from request, where request path is test. So that would be one path, and just separately, just so that it's easier to play with this. Ping will do that, and upon ping. So basically two things here. And what we want out of this is something like with test and also priority. I forgot about priority because we need to sort them somehow. So priority integer not null. And we'll order by priority descending so that the highest priority gets to the top. So what I want here is with test, and also I need to supply priority here. So priority will be priority. With test, select, so basically I can copy all of this. Select test as, and I also want ping to be as select this one. And remembering how we've done this in the test, I don't want to write it by hand, and that's exactly why I want to figure this out. I don't want to write this by hand at all. So we'll take two of these. I'll go to the scratch buffer here, and so I want to select from tests, and then I want to make a union here with ping, where where test did not return anything. So basically, if test failed, then I want ping, and then we're missing priority here. Priority, that's going to be priority 1, and that's going to be priority 1 because they are of the same priority. So basically, it doesn't really matter in which order they will be returned. That's fine. Yeah, that's basically what we want to do. And I probably want to test this query just so that you understand what's going on. Let's write it the same way we're doing here. Let's make it easier. So let's take this query and let's update a listen. Well, let's see, table listeners, Omni HTTPD listeners. So 9,000 is the one we're looking for. So I want to also look at handlers. Yeah, I actually didn't need listeners. So handlers, number 1 is the default one, but number 2, that big one, is what I want to update. So I want to update Omni HTTPD listeners, handlers, set set query to this big string. So this where AD equals to, and everything crashed. That's funny. Because there's a bug apparently somewhere. Let's see what went wrong here. So there's an error preparing the query. Omni HTTP response. What have I got here? Oh, it's HTTP response, of course. So let's go back to the Scratch buffer and HTTP response. That's what we wanted. And let's edit it. HTTP response. Update it. So let's see if that worked. So if we did 9,000 test, we get in test. If we wanted Bing, we get in Pong. So this query works as it intended to work, and we can move on to the deeper details. By the way, there's a weird thing here. I'm somehow missing the chat window in my streaming setup, so bear with me. I'll try to find it. A few chats somewhere. I don't know. It would be nice to see if anybody is writing anything. Let's see here. I'm also notifying Twitter listeners that there's better quality on, for example, Twitch or YouTube. Just so that they can see this. But yeah, I can't see my chat screen. Even though you can see it, I don't think I can, or participate in the chat. Oh well, let's see. Not this one. Yeah, it's not showing up for some reason. I don't think I can find it right now. Interesting. Also, I'm using OBS, and for whatever reason, that's just not happening. Where's my chat? Nowhere. I guess I'll have to do it without the chat for now. Now let's see if I can pull up another screen where see the chat. I think there is a way I can do this. Just bear with me. So at least I can see, I think, Twitch chat, which is not a whole lot, but should be enough for now. And I don't think there's a lot of people there anyway, or anybody really, depending on the platform. But yeah, at least I'll see the chat. And if you have any questions, let me know. So yeah, basically we need to take this and this input and turn it into this, which I think would be really nice because it's kind of a much nicer way to organize your routes. You can put them into a table, or you can simply create them on the fly. Like, you don't need to put them into a table, right? So that should be okay. So let me go back into OmniSQL and its relationship with OmniHTTPD. So OmniHTTPD actually depends on OmniSQL, but even though OmniSQL is an extension, but it's also a C library, so that I can use its functionality without requiring Omnigres users to install OmniSQL directly. And you can see it here. So there's lib OmniSQL, which is defined here. And it basically gives me the general functionality of the library, which is basically parsing statement and adding CTE, because that's a very common piece of functionality that should be part of OmniSQL as an extension and as a library. And there's also checking whether query is parameterized and stuff like that. But I was thinking that this function that we imagined, the cascading query or something like that, is maybe not going to be a good candidate for inclusion into OmniSQL, or maybe it will be, but we can decide about that later. So I wanted to implement it as part of Omni HTTPD. So that's, I think, where libOmniSQL can be useful. So we can basically rely on the library for parsing and deparsing. But for the rest of it, we're still going to essentially use Postgres' API for manipulating the query. And that's basically what's happening here. So OmniSQL add CTE, which we actually can reuse, I guess. It's manipulating the query to add a CTE expression, and that's exposed through SQL API as well. But we just want to use it from C. Okay, and let's see. I also wanted to check something else here. Okay. Let's try. So we are going to define a file somewhere. So Omni HTTPD would want to have an aggregate function. What does it mean to us? So basically, we would need to define the function in SQL and also in C, obviously. And I'm just thinking of what else we need to foresee there. I'm just looking at my previous notes. Docker, it's something else. Okay. So let's go back to our file here. So we need to define this function. So create function cascading query, and it's going to be name text query text, and also priority integer, I guess. And we will need to, so like it's not a function, it's an aggregate function, right? So it's going to be a lot more fun than that. I'm just pulling up some documentation just so that I don't have to type everything out of my head. Create aggregate. So let's say let's comment out for now. Create aggregate cascading query, and it will take text, and integer. Okay. Also arg name, actually, we should probably do this, otherwise we'll forget who's who. Priority. So now let's think what we need there. What's the absolute minimum we need to do there? Is going to be sfunc andstype. So sfunc equals cascading query so we're essentially reducing over to this should I actually like this, just so it's a little bit nicer. So and then I need to specify the as type. And the type of this is going to be text. So with every iteration, we're returning, sorry, not as text, as type. And we didn't create the function yet, so create cascading query reduce. Query reduce. Okay, that resolved. What else do we need? Can I actually implement this in PLPGSQL? I'm thinking, like, do I have to implement this in C at all? Because why not? If I can, I would rather do that. Good question. So what I'm doing there, let's go back to the Scratch. I am so yeah, basically I need to take the actually I don't need to specify priority here because I'm already doing the sorting for it, of course. So that's simply I'm just ordering here, and I'm just applying this, so we can go back and remove the priority as unnecessary. And it makes it much easier. Okay. And the initial condition of this, I probably need to specify it too. It starts with, I guess, an empty query. So condition would be select and just nothing else, because it will return nothing. So guess that's okay. Okay, and then no, actually, we don't need to return string on every step, right? So obviously that would be just wasteful unless. I'm just trying to make it simpler, and I haven't actually written a lot of aggregates in C. I've done this more in Rust with my work on PGX extension. Um, and I'm still trying to think what would be the best way to do this. Um, mm, okay. So obviously I would still need to define this as a language C function. That goes without saying. Just need to complete that. Returns, well, let's think about it a little bit later. Returns text if we want to always reparse it. The reason why I'm thinking about this is it likely can't return the node structure because it's going to be the structure here. I'll show you. Basically, it's going to be a bunch of statements, and there's a lot of pointers there, and every time, like if we allocate them in the memory context of every invocation, obviously that will not work. But when aggregate state type is declared as internal, though, so maybe we can actually use an internal state here. It combines function responsibility that the result is allocated, etc., etc. So internal state type may be actually what we're looking for here. So I'm just reading the documentation here. The most common case is where the aggregate support functions are to be written in C, and the state type should be declared as internal because there's no SQL level equivalent for it. Yeah, obviously. So state type. But what I guess was referring to when I was looking at the example, again, can we do this without without resorting to C? So if every time we get the name and the query, we can augment the query that we're working on. I mean, it's not going to be efficient, but we can do that later. You know, if we need to parse and deparse the query all the time, but it's not going to happen all the time. It's only when you're recreating your query. So performance is not really important there. So we do have the add CTE functionality. The thing that we don't have is actually unionizing these. So basically, like adding the unions. So, but the other problem here is Omni HTTPD does not directly depend as an extension on OmniSQL dependent extension, and I probably don't want to introduce that dependency at this point. So it still has to be C. So let's go back here, and so we specify this as internal, and combine function. Basically, we need to take combine function and produce new state data type. It's not the combine function, it's the final function that I actually want to call, and it's basically internal state. And okay, so the final function would be cascading query final. I don't have a better name for it yet. And in the query, I want internal here. And next data values, that's going to be oh, sorry, not a func, it's final func. Final func returns internal here. And what else am I missing here? Language C, and to the module path name, that's going to be cascading query reduce. Let's format it a little bit better. And then I also wanted to do cascading query final. Internal only, and it returns how do we call final func? It's it should return aggregate value, right? So S type, state data type. So for arg data types, we are using 2 of them, obviously. So the return data type of the aggregate is defined as the return type of this function, right? So it returns text because we don't have OmniSQL extension, so we cannot use the OmniSQL statement type. And we'll do that. but sfunc, it should take n plus 1 argument. So the first argument is the state data type, and then the rest match in the declared. We don't want this. Yeah. So query and also name here. Name text. Okay. So obviously this will not work yet because the functions are not there yet. But let's go and do this. Let's create a C file. So it's going to be a C file. We'll call it cascading query. I don't love the name, but it's okay for now. I mean, yeah, that's okay. So cascading query. So we'll add it here. And we'll copy some stuff around just so that it's easier. We'll copy things like this. Cascading query. And we'll include lib omni, where's it? Omni SQL h. And now we can pg function info cascading query reduce and final. Did I call it final? Yeah. I'll figure out a better naming later. So now it's going to be data on cascading query reduce pg function args, and there's going to be final here. Okay. Okay, so I know creating return sets is not fun, but I'm actually not doing that. So it's not set returning, but it's just a cascading query reduce. So that's just a reducer and state. I need to specify state still, I think. Init const. Let's see. Do I actually need to do that for my case? Initial condition. Let's actually do it here. Search for init const. Create aggregate is probably a better place for this. Init const. It also looks like my layout for this screen or scene rather has messed up, but I'll fix it for the next stream. It's good enough for now. I haven't done streaming in a little while, so it's basically null. That's okay. And if it's internal, then can we do anything we want? Let's see. So we are getting PG. The first argument is the state. So if PG arg is null for the first argument, if it's null, right? then we need to create something. We need to create a query that will be our state. So statements. So if this, otherwise, let's imagine it's not null. We already have something. That's going to be here. Do we do anything with that? We'll see. Okay, so we have OmniSQL parse statement, and for that we need to take the query, which would come from the parameter, and that's going to be the second one. So 0, 1, 2. pg arg pg get arg. That's going to be text 2, but we actually want a string out of it, so it's text to C string. We all obviously need to, well, we don't want to make an assertion here. So basically we need to ensure that the query is not null, because if it's not, we just should return. So if pg arg is null 2, so we'll just error out saying that query is required. Query can't be null. Same should really apply to names realistically. So let's define state arg state 0, define arg query, no, arg name 1, define arg query 2. So arg name can't be null. For now, in the future, I think we can auto-generate this stuff. Arg query can be null. This is arg state. So if state came this way. So we'll get it from the query. So we'll parse this statement, and it will fail here with an error if the query is not correct, which is good. And it returns statements. Okay, and it should return next internal state. So pg return pointer, I think. Statements. Problem is what's going to happen here in terms of memory context. I think it should be fine because we're still executing the query, so we're still living in the right context. Statements. Yeah, and it could be uninitialized for now. But here we actually should do this. It's pg get arg. Actually, no, not here. Probably it's better. For logic of this, statements will be pg get arg pointer arg state. It really shows that I have only done much of my aggregate work in PGX. Anyway, am I talking too much? Too little? We'll see. So now we have this, and let's say here we want to return text, which would happen by deparsing the statements which we get from the state, which is actually kind of interesting. So if there was nothing, it would return null because there was nothing, right? So we still need to address this case. So if the state is actually null, then we initialize it to something. Otherwise, we're taking what we're given. Statements. Otherwise, we are statements. We're not going to parse something. Let's say we're going to parse select. Like a better idea. Okay, and we parse it and deparse it, but we need to do something about it here, or maybe not here. We'll see. I was thinking, so basically we need to do the union things and the CTE thing. So CTE is probably easy. So let's see. We'll get text name, and that's PG, get arg, name. No, arg name. So that's our name, and we already verified that it's not null. And we can try add a CTE to our statements. And the other parameters are the CTE name. What else? CTE name, which is what we got, and CTE statements, which is something we can parse, and the recursive and prepend. So the name goes here, and then we should probably parse something like the query that we just got. So that would be pg get arg text. We already actually got it here. So let's extract this. Text query here, and we can just insert this query here. And then we can, we don't need the whole macro here anymore. We can just insert query, which is our, actually parse statement that takes characters. So we actually can extract this whole thing. So text to string, and then just char query, and just parse this statement. Query. Hold on, we already done this. That is where it's wrong. So basically we needed to parse select here, I think, because this is kind of the trunk of the query, and that should be in our state, but we're sticking those queries into CTEs. So let's try and work this. So here we're adding this, and it's not recursive, and we are not prepending. We don't care. So this potentially should just create a query, and I'm not bothering to do union just yet, just because I want to figure out whether we've got it right with everything else, like, you know, how we define the aggregate and things like this. and whether this code is anywhere close to correct. There's probably tons of mistakes everywhere. So let's fix those first, and we can get to union after that. And I think I will be finishing this screencast in half an hour. Running out of juice here. Okay, get our pointer. Yeah, that's right. Where was it? 31. Arc state statements. That's just from pointer. Yeah. Guess we do need to cast it, but that's one thing. What actually failed there was line 50. Yeah, I just need to return depart statement. Let's try. Create extension omni httpd. I didn't do it right. Oh, here we go. At least on the SQL side, there's nothing bad. Do we want to take the scratch just for fun? Scratch and do exactly the way we kind of anticipated this. So let's create this. That worked. And now, are we getting anywhere? Aggregates cannot use named arguments. Okay, I didn't actually know that. Okay, let's try that. Routes priority should appear in group by priority. Oh, wrong order. Because we're aggregating. Oh, and there was a crash, which is a thing that happens very often when you write it in C. But first I wanted to also verify if create extension here. I just wanted to see if what I'm returning is correct here. I made a mistake copying here. And then let's select everything from routes, group by priority, order by priority. Oh, yeah, everything, of course. Name and query. I'm not in the correct place. Name and query and priority T. Yeah, so ping and test, that's exactly what we wanted. But we have a bug, and let's fire it up. So debugger, here we go. Attach to this. This is our process. Let's continue with it. And yeah, we could have actually done this better. Used to switching between tools so much. Continue. Exit. Let's attach to process, and that's going to be pause. Let's search by idle. Yeah, this one. We might need to move the debugger somewhere else. Oh, I think I moved it too far. You don't see it anymore. Let me just put it back. So you can see the debugger. That's fine. And it's attached. So let's go back to the terminal. Try to trigger it. It's Getting query. Here we are. So basically that's where we crashed. Let's see. Oh, I see. Like it can't really show as much here because I'm compiling this without debug information. So let's stop this for a second and just rebuild this because it's not going to be useful. So cmake, so that's going to be debug build. So let's reconfigure it. Okay, almost done. That's actually a slow way to do this. I usually do this so I can build on all the cores. It's a lot faster. Here we go. So let's create extension, and then let's copy that scratch of ours. Also attach the process first. Idle. Yeah, this one. And where's our scratch? Here we want this. It should fail, and we should try and see where was the bug. Here we go. That's a little better. So basically, the exception is, well, we're trying to access something that obviously does not exist. And our statements are pointing somewhere. That's good. But basically the error is here. So we are trying to look into the list. And our list here, statements, is this. Length of bond. And basically it fails on that address. So yeah, elements are just basically not done here. Okay, and so we parse the statement. Okay. So the question is, do we actually parse it? Or did it come as a pointer? Well, it should have been null originally. That's a good question. Let's see. What about Postgres aggregates? So how do we behave there? Yeah, I think the important part we're missing here is basically, well, we know it's going to be an aggregate, right? So, but we do want to check that. Aggregate function info, and basically, what is it, the type there? So basically, we need to let's see. So basically, if you want to store the memory context where this is happening, text memory context, we just take this memory context here. And if this is not true, right, it returns Boolean. So it should be a regular aggregate. If it's not one, let's return an error. Port error must be a regular aggregate. Say regular aggregate. Okay. And then all the allocation that we're doing should happen in this memory context. So memory context switch to, it's going to return the old one. So memory context, old context, switch to memory context, and then basically switch back to the old context, just for sake to say, old context. So that's one thing. And here we again kind of need this, but ffunc, I'm not sure. So the finalizing function memory context, how should it retrieve it? Let's see if final does or does not need this. So let's try and see. Yeah, these crashes are not pretty. Let's actually do the following. Let's go back to our Scratch and create extension Omni HTTPD, just so that we can copy the whole thing. And actually, well, we know how this should look like. We already tested it, so easier this way. Let's restart it again. Okay. So this is what it returned. We're kind of getting there, but not exactly. So our we kind of see what's going on here, and I think the mistake here is because this is returning a char, but actually we want the string to text. Okay, so let's just rebuild it, and let's insert the whole thing, and now see what we get here. So with test as that select from request where path ping as, and now we have the trunk, and all we need to do now is basically combine this with the union, and what do we do here? So first of all, we need to know whether there was anything yet, right? Like if it's first time, we do just select, and maybe we can actually move this. No, we can't, because add CTE. Yeah, we already have to have it at this point. And so that maybe we can set a flag here to indicate that whatever we had there is just not important. We'll initialized true, so this means we already have the query, but initialized false if we actually had to just stick in a temporary one. And in any case, well, if it's the first one, right, so we need to construct it differently from others. So if it wasn't initialized, so it's the first one, what we're doing here is we need to have a query like select. I already deleted it from the scratch, but let's restore it here for a second. So it's select from, like select everything from test, and then union all. That's, well, we'll address that when we get there. Cascading query. Basically, for the first one, we need select from name, and that's all. If it's the follow-up, we need to create something like select from name in the scratch here, where not exists, select from the previous one. So we kind of need to know the previous one, which is based on priority or whatever we added last. Yeah, that probably works. So we need to do this way. And as a second thing, we actually need to union with the one above. But let's start with the first one. So here we know the name. That's good. So maybe we can just do something like select from, let's quote it just in case. No, okay. Select from, actually, yeah, should probably quote, because they can specify anything they want. So eventually we actually need better support for quoting here. Like, what if they use quotes there? But we'll get to that. Like, that's not the meat of this. So basically, it's a string here, and that's gonna be text to string name. We can also optimize this by working directly with the name without allocating a string here, but that's an optimization I can do separately from the string. All right, so that's the query we want, and we can parse it. So that's going to be our select. It's actually going to be a list of selects, so I don't want to add all of them, I guess, but which means I need to go and modify the query there. So let's look briefly into add CTE, and we'll see how I'm doing this. That's fine. That's how it should be. So basically, I'm getting the node, which would be, in my case, I'm basically creating the node. Node as a common table. No, that's the CT node. The node comes from, like, this is the first part of the extension. Sorry, extension statement. So we can do the same thing. So we say that our node is that, and we need to find our select statement. So basically, there should be a select statement because that's what we put in there. And if node tag node is not equal select statement, then it's an error. And it's actually, it basically should only happen if we made a mistake in our code. It's not user error. So we need to assert that it is a select statement. And if it is a select statement, we can cast it just like here. So we'll get a select statement. And redefinition of select, where, yeah, it's actually, we don't need that. We basically, because we're discarding the first select here anyway, so we basically can change the, like in that list, we basically replace the first element with the, I think it's L first of the statements, and there's kind of funny difference, but it was like L first. Why is it not getting imported? I think should be fine. And L first node, and maybe just override there because it has to be that. We know L first node equals to select. Not sure why it's highlighting. Let's see. Maybe I missed some header. Yeah. Function like macromutation. Oh yeah. Type. T select statement. So it's a cast of a node to this. L first node, and it basically goes to L first. It's a pointer that it gets. Just thinking lists. What's the best way to overwrite it there? So basically what we need is we need to take that expression and replace it so that's going to be our deselect statement original, but we don't want that. Basically we need to take L first of statements, and there's going to be, so this L first of statements, it's going to be a pointer value, right? Equals select, something like that. Of course, because there's statements. This first, the data in this const cell, right? It's a cell. Initial list nth cell, maybe. List nth first. Oh. About list nth, is it what we want? Return to the pointer value contained. Yeah. List nth cell. List statements as 0, and pointer value should be selected. Am I right? Am I right or not? Let's try and see what we get out of this. Again, we can remove this part. Just copy. What is that? No supported statement found. Let's remove this again. It's an error coming out of, I guess, parsing there or something. Let's see. Also, my wife is messaging me. Let's see what it is. Okay, wife says come for lunch when you're ready. Well, let's get it done. What are we parsing here? Select start from as text to string. That's where it's failing, I suppose. Text to string, okay. Select. So it's basically like select from whatever, basically. Let's say which table have routes. Yeah, so obviously. But no supported statement found. Is it because of this? Or is it because of parsing? Let's try. So yeah, like that was not the parsing that was causing the failure. This is do this. And cell start counted from 0, so elements. Interesting. So I'm taking the statements and I'm trying to replace it with the select. But yeah, what I'm not getting here is actually L initial, because it's a list of statements. It's not just one statement that should be select. And we can also make an assertion here. So assert that L initial, well, let's make it like this. T select state, T select statement, select statement is L initial select, and we can assert that this selects, what do we want to assert? That it's node tag of select statement. What happened here? Undeclared. Oh yeah, of course. It's node, and we want to make sure that this is tsec, because this is not a type. This is constant here. And what we do here is we're putting select statement here. And what happened here? Yeah, we forgot the semicolon here. Let's try. Let's copy the whole thing again from our scratch. And we have a crash. That's good. Failed assertion. So the select statement of the initial node tag is not that. Because it's raw. Yeah, it's actually raw. I've encountered this. It's a raw statement, and then we can let's rename this to node, and then we'll just reuse it saying L initial. Node is, how do we deal with this here? We basically takes it's a raw statement, so it casts it to a raw statement and then do this. So we can just embed this casting just so that we're not creating anything new here. So let's cast, oh, that's not the right one. Cast node, raw statement node, and then take, let's make it nicer. Cast node. So basically here we're taking the raw statement, taking the actual statement out of it, and then that should be T select statement. And this is not appropriate here. And let's try. Let's restart. Let's kill that dead Postgres. And let's restart. whole thing. Row statement with an empty statement. And that is happening because we're actually not doing it right. We need to take nth cell of node. Actually, maybe we should introduce this row statement. Not that. Row statement, except that I don't like this name, row statement. And we just change node to that. But what we need to do here, so basically we got to our node being this, and we need to take so we need to cast so we need to take a first element of statements, and that will be our initial node. So we can also assert that. So assert L initial, well, let's actually do this first and then I'll improve this. So L initial is our row statement for this statement. So then we cast node row statement for that. And then that's going to be our statement here. And that statement is a node, and basically, can we just do something like this? Just thinking. So node is already what we gotten from our new query. Compile it at least, but no promises on crashes. Okay, so here, we have success. So as you can see, it's with ping from request, so there are two, like from request where request is ping, but also the problem here is it did not add CTs correctly because it like skipped the test, got the ping. We'll have to figure that out, but it did add the proper select from test. And this can probably be improved. Like I can try constructing this by hand. I don't want right now, because I think for the purposes of the session here, it's easier if I keep it like this, but I can improve this. Anyway, so if we want to do this, I'm wondering like what happened actually with the CTE that we've done there. Did we name them incorrectly? No, I think that's not really the case. So scratch. Yeah, like that couldn't have happened in testing thing. But it's interesting that it's only processing one. But we can insert some debug login and see if anything is happening. This new one is select from that, but where not exists, select one from the previous one. And the tricky part here is that we don't know the name of the previous one yet. And we'll still need to do the union here. But we're getting somewhere, right? So the name is fine. And let's remove all of this funny stuff. So let's just make it really succinct here. Not node, but initial select, because we're controlling this and it's kind of more readable this way. Node. Maybe just do it like this. For now. It still should do that same thing that is not correct, but that's fine. Well, actually not fine. Let's put an empty string here for now. I won't do this, of course, because we need the whole thing. So that's fine, but it was 0 length, so that's why test. That's just for the time being. So it didn't do anything to our query, but it still, did this thing where it did what it did. Okay. So yeah, I'm still wondering, like, where did this go? I think I know what happened. Yeah, so basically we made a mistake here. So we took the raw statement and replaced the whole statement, and that made the test route go away, which is not correct. We actually need to do a little bit more work here. So from raw statement, basically, if it's a select statement, we need to change what? Basically, we want everything but the with clauses. So we kind of need to copy, well, not necessarily copy, but let's say statement, and that should have been a select statement because we know it's always is. So cast node t select select statement. This. So now or actually we can say that this is our new statement. No, this is not good. So we hold on, this is the initial case, right? So that should have been fine because like we're just throwing out whatever was there, but we're throwing out the CTEs. That what happened. That's why we want to do something else here. We want to move the CTEs into this. So basically this is our statement, and then we cast node select statement, and then with clause is actually coming from our statements with clause. We also need to cast node raw statement. We'll extract this L initial statements, and then here, this is the way it should be, and then we cast this node to select statement and get the with clause from. So we're kind of moving it there. I know it's not pretty, but my job will be to prettify that. And then we say that this statement should now, in fact, point. So this statement should point to. I'm getting confused, but that's okay. Initial select here. So we'll extract this. Oh my god. This is going to be. No, that's correct. That was actually correct statements here. But we want to extract this select statement. so that we can also, this is original. Oh, what happened here? Original select statement, and but we got too far. Actually, we don't want select statement. We want a statement. We have one raw statement. Raw statement. Why this didn't work in raw statement? I know. So we need original statement, but then select statement. So separate this to original select statement is cast node select statement from original statement. So we exchange these, and now we can say original statement this equals original statement equals select statement. Am I right? Am I not? We'll see. Okay, there was a problem, of course. Select statement is a node, and it can, yeah, it is. So let's get our scratch back. Should be finishing soon, hopefully. We're getting there. So now you can see that I have both with test and with ping, and all I'm missing is essentially select star from the second one, like from ping. And let's see what we can do there about that. So let's go back to cascading queries, and this is basically the case we're handling here. So first of all, we need the name for previous name. How do we do that? So we do know that we add CTEs as we go. So this should be kind of the last one. So let's see if we can do something about that. So how about we get the row and select here, because we kind of gonna reuse them. And so if we take the original select statement that we got, original select statement, and we have with clause there, which contains CTEs, and we want L initial and what is it, like I want the last one, L last, I guess. No, L last is similar to L first, but so the macro first, because if we look at the L last, it looks like L initial, so it should be fine. Yeah, L last of this, and we're specifically looking for node type, I guess. Node, and the node is CTEs. It's a list of common table expression. And what did I like about this? Type and list expected expression. Not sure what happened here, but comment table expr, that's what it is. And now we need the CTE name, the last one, right? So what if we insert previous here, previous name. And now we need to create a union expression. So we need to take the existing select, which we already have, original select statement. But yeah, it's kind of funny because we already have CTEs, but let's see how it works and then we'll figure it out. So basically we need to, let's see, we need to take the original select statement, and it has, I never worked this union, it's different, I guess, here. Because union is not here, I suppose it's union. Is it recursive union? Not sure this is actually what I'm looking at. It's plan nodes. T union. So T recursive union tags for plan nodes, executor nodes, and T select. So for statement nodes, because that's what we're looking for. I just need to figure out basically where unions are, because I never really looked into that. Let's see. Select. Getting hungry, but let's get it done, like, or almost done. We need to Postgres node union. Parser. Just trying to figure this out. So that's where roughly it is, I think. It's a query tree. No. Let's see, it's original statement. Set operations is not there. I mean, one way to do it is just to test, like, parse a query and like, okay, let's do that. Let's omni SQL parse select one union select two, just for, you know, for the fun of it. So it's list, and we'll take initial element from this, and actually gonna initial node, and it's gonna be a row statement, and then we take the statement, and let's see, statement type, node type. Can I get string version of node to string? I think that would be node to string is the best. Kind of, yeah, node to string. What will this tell me? Your report notice such. Let's just print it out and see what it has to say. Let's copy this. Basically, it was select Is there anything about union here? With clause, operation 1, all false. Left arg? So it's L arg, I guess. And right arg, right? Let's see. So let's comment this out for now. So if we take this, well, we don't need a lot of this original select statement, L arg and right arg. What is it? Left child, right child, so it's type of setup, right? So I didn't see that up, because I was searching for set. It's up. Set operation. Well, we are assuming it to be union for now, because that's what it is. Set operation. Yeah, it's like union. But we haven't created it yet. So basically, what we need to do here, we need to define a new node. So allocate. Is there any way to allocate node, or is it allocated new node? There's all perfect. Alloc 0 fast. Node, new node, and it takes it's make node of type actually. Make node t select statement. So we're creating a new select statement. Select statement node cast node select statement. It's taking this, I'm pretty sure. Yeah, perfect. So basically we're creating this union up, that is called setup. And setup is up gonna be union, and setup left is larg, gonna be what we already had, original select statement, and setup right arg would be what we just did, select, except that we want L initial node row statement select, and that gives us the statement, and then from that we can cast that node to select statement, just for them. And basically our statement should actually be updated now. Is original statement equals to select to set up, something like this. There was a mistake somewhere, I'm pretty sure. It's because, yeah, I don't need to cast it really. Oh, sorry, not this one. Set up. Okay, well, here I didn't need to cast it here, just back to node. I'm wondering if I need to set up anything else here. We'll see. Here we go. So we actually got select from test, but it kind of got in a weird place because we got the CTs inside and we need to move that. So basically, we didn't promote the cities to the right level. That's fair. So basically, we need to so this setup should inherit the with clause from the original select statement with clause, but original select statement clause with clause should lose it. Let's try it. Ta-da! I think we're good. So it selected start from zero test union, select from ping where not exist, but it selected it from ping again, so that's wrong because the last one already here. So we added the CT too early, I guess. We need to add it later. Otherwise, basically the last one is the last one we added now, not in the previous iteration. Perfect. So now we're actually selecting from test for ping. I think this is pretty good. I mean, obviously there could be some bugs, leaks, or whatever that I will still need to think about, and I can do some optimizations, but I don't have to do them because this is not sort of a busy, path. But what I can do here is, in some places where it is important, I can go and change this. So basically, well, I can rewrite it later. I think it's been going on long enough. But yeah, basically, we got this thing, right? So we can now update. Let's say we actually are serving this, so on port 8080, right? So what if we update handlers, set query to the result of this, basically, for everything. Just don't care. Obviously, I need to specify the schema. And something didn't work again. And the reason for that is, again, my code was not correct here. It's HTTP response here. So let's clear out the routes table, delete from routes, and now let's redo this. Actually, redo this part. Here we go. And then we had this thing where we're updating handlers. Now we've updated it, and if we request ping, we got a pong, and we request test, we got test. Perfect. So I think writing like this is a lot more fun when you don't need to write all of this stuff. So I will just clean this up a little bit and send a pull request. I think I'm done for now. Yeah, check it out. Let's see where this journey will take us.